special signature that is added to the answers that are given by DNS. And the intent is that you want to be sure that every information that the DNS is given, you can actually confirm them to be real, and you can also confirm that they have not been changed. So you imagine that you're sending a letter to a friend and they ask you for an answer, or you ask them for an answer and they gave you that answer. So the question would be that, how do I know that my friend is actually the one who wrote this answer? How can I believe, how can I rely on that kind of information? So that's what DNSSEC does. So with DNSSEC, so you will see in that answer a special signature of your friend. That signature is only known to your friend. So you identify that signature and you will know that this is from the friend. So it is DNSSEC that does that. So DNSSEC is just the security extensions of DNS, that's domain name system. Now, what does it protect against? That will be the next question. What attacks does DNS security extensions mitigate? The first thing is what we call DNS spoofing. And by that, in a simple terms, think of hackers pretending to be DNS. So these guys that are saying, I am the owner, I'm the one handling this DNS service, but they are hackers. So they are pretending to be. And every answer they are giving, you could be sure that they're going to be misleading. They're going to be fraught with malicious codes, malware, and other things, or identity theft tools. So how do you protect against such? So we use DNSSEC to protect against DNS spoofing. It's imagining you are asking for direction from a friend. You think this guy is your friend, not knowing that this guy is actually in a network of kidnappers. And that guy is actually leading someone to the den of the kidnappers while the guy is pretending to be a real friend. So DNS spoofing is that, and DNSSEC helps to protect against it. There is another thing called DNS cache poisoning. Again, think of it this way again. We have some bad guys that put fake information into the DNS memory. Like someone maybe, for instance, sneaking into your library, the library, public library, and the good books are infiltrated with bad ones. And for the people that want to use it, maybe they don't even know how to differentiate between these two, the good or the bad. They believe that anything that is inside that library is an authentic library. For instance, let's say kids. So a kid is sent to a library and you have told the kid that whatever you see in that library is actually good. But someone has gone there to poison the books there. That's to put in some books that are not meant, that are not ideal for kids. So that library has been poisoned. So also DNS, the phone book or the library, the phone library of the internet could be poisoned that way. And that is what we call DNS cache poisoning. Another protection it offers, I mean DNSSEC now, is it offers protection for zone transfer attack. So this again means that we have these bad guys copying the entire DNS database. So they steal everything. So imagine someone just copy all the entire information in your phone book for malicious use. So that's the zone transfer attack. It's an unauthorized copying of entire DNS zone database. Now, we need to take note of this. DNSSEC does not include, or I'm sorry, it doesn't hide questions. It just makes sure that the answers are correct. So that's what it does. It ensures that any answer that is given is a correct answer, because it would have protected against DNS spoofing, DNS cache poisoning, and DNS transfer attack. And we look at directory services, secure directory services. That's in secure directory services. Let's look at it this way. We ask ourselves, what do we mean by directory services? Let's look at it this way. Imagine our kids in school. So they have what they call the main office. And in that main office is the administrative building, the administrative block that knows the information of every person in the school. The admin block, because that was where the registration started. So the details of everybody in that school, both the teachers and the students, the parent address, everything is not known in the school main office. So that's the directory service. So in directory service, we have the subject, we have the object, and we have the permissions. So in the object side, so this has to do with the people, the users, the computers, the networks within the system, then the services. Think of it like students, teachers, and computers in the lab, like we said in the case of main admin block. Then we have what we call the objects. So the object, we'll be talking about the directories, the files that are in the service, the folders, those are the directories, then the files. Then the other one is the permissions. So these permissions will make us know what subjects can do with object. For instance, what can a user subject do with the directory object? What can a computer subject do with a file object? What can a service do with a subject, I mean, as a subject with directories or with files as an object? So permissions specify the relationships or the rules that guide what rule of engagement between the subject and the object. For instance, in the admin block, we say we have information about the teachers, then we have the students. So we know that the rule states that only the teachers could mark the script and grade the students, and they are the only one that can change the grade. So that is the permission rule as it relates to the teachers, one of the subjects. The students, even though they are part of subject, they are subject, but they don't have the rule, they don't have the permission to upgrade grades. So this is a situation where we have the relationship between object and subject. So the permission is what guides that. Then the point here is that there are some directories that are open. Sorry, there are some ports, I said. Port 389, for instance, is an open port. And what do we mean by open port? It means, think of it like a door with number, but it's not secured. Anyone can just open it. So those are some of the ports that are open ports. Most directory services, they use LDAP. That's the Lightweight Directory Access Protocol. Now, what do we mean by LDAP? As it's stated, it means Lightweight Directory Access Protocol. But what does it mean? Simply, it means the language computers use to ask the directory questions. Like, for instance, in terms of email, what's this person's email? So that's the language that the computer will use to ask directory. We call it directory service. So to relate with the directory service, so the language that is used to ask such a question or to relate with the directory service. Or for instance, is this person allowed to change the grade, to change this file? Is this service, this subject, is this user, is this computer allowed to do this? Is it permitted to do this? So LDAP is the language that is used to find out such pieces of information. And the port that it is using is port 389. This port is open, and that's why it is unencrypted. Okay, so the question now will be, how do we log into LDAP? How do we log into LDAP? So you can see LDAP authentication methods. No authentication is anonymous access granted, simple bind, is SASIL, is LDAPs. So what do we mean by this? No authentication means anyone can ask questions. Anyone can ask questions. Imagine in the library, in the institution, any registered student is allowed to enter that library. So there's no need for authentication. anyone can answer, can ask questions. That's the first one, no authentication. The second one is what you call the simple bind. What do you mean by a simple bind? Simple bind simply means, for instance, you give your name, for instance, and your password, and it's not hidden. Like you write it openly on a postcard. That's simple bind. That's DN plus password in plain text. It's not encrypted. Then the other protocol there is the SAS, which is just a smart way that is used to negotiate the best security method to use. Example is the Kerberos method or Kerberos mechanisms. Then LDAPs itself, when it's using a port 636. So when you have LDAP and now you have LDAPs, you see there's an addition of S. That S is the security. So LDAP is what we've talked about earlier on, lightweight directory access protocol. So when the S is added to it, so we have our LDAPs, and this one is on port 636. You will see LDAP is on port 389, but LDAPs is on port 366. 636. So this port uses TLS for secure tunnel. So this one is secured, unlike LDAP that is unsecured or unencrypted. So it uses TLS for encryption. TLS simply means transport layer security. So what do we mean by this? Simply means a way to, when you scramble your information, so information scrambling to ensure that the right person has access to read such a scrambled message. So those are the authentication methods in LDAP. No authentication, that means anyone has access in simple bind, plain text, password, and username. Then the SASL method. Then the LDAPs secure protocol, which combines TLS security mechanisms or TLS encryption with LDAP itself. So the next thing is to look at time synchronization. Time synchronization, we call it NTP security. So what does it mean? NTP security, why does it matter again for computers? Why does time matter for computers? Now, NTP simply means network time protocol. Network time protocol. That's the meaning of NTP, network time protocol. Okay. The major purpose, the main intention of NTP is to ensure that all computers agree on what time it is. That's very important. Very, very important. It might sound silly, but it's a big thing in security. Imagine there is a case in the court. Someone is claiming that he made a payment. This is this so date. And this other guy is claiming he didn't receive any payment. And they said they should bring, for instance, the alert, the transaction details. And it turns out that even though these guys are in the same time location, but there is disagreement or there's disparity in the time measurement because the protocols that are being used across their systems are different. So this is a very important protocol. Network time protocol is very important. It's very, very important, and it matters for many reasons. For instance, security certificates have expiration dates. So if you don't use network time protocol, how do we know when thing has expired? The expiration of security certificate. How about logging correct times? So there was a breach at this time, this seconds. And because the network time protocol is compromised, there is a problem when we need to figure out things or when we want to do audit or forensics. Another thing is that there is this mechanism we use, which I just talked about, the Kerberos is a login system. It will not work if clocks are off by more than 5 minutes. It will not work. So network time protocol helps to ensure this critical aspect in time measurement. Now, NTP uses UDP port 123. 123, that's the UDP port it uses. And UDP, what does it mean? It simply means user datagram protocol. User datagram protocol. It's just a way of sending data, but very fast. UDP, we have different ways of, we have different protocols. I think you are using UDP. Yeah. I think you are using UDP. That time when I asked you to run some code, I think I saw one of your protocols to be UDP. So it's very fast. So NTP uses port 123 and it uses UDP, that's user datagram protocol. But the problem here is this. The original NTP had no security. That means anyone could lie about what time it is. But what's the solution? Now that's a historical issue. NTP has historically lacked security mechanisms. The solution now is to bring in something which is known as NTS. NTS, that's network time security. From network time protocol, we bring in network time security to fix the security problem associated with NTP. So that's where NTS comes in, S standing for security. It's actually a security extension that is developed for NTP. So what are the features of this upgrade? Number one, it uses TLS. That's transport layer security. It's an encryption method to verify the time server is real. This is used for verification of times in the server. Then it also makes sure that no one changed the time data while it was traveling. So that means at transversal points, the data time cannot be modified. So if you have sent it at this time, as long as it is in transportation point, it will not be altered. So it uses TLS for authentication, ensures time data from trusted server, verifies data not changed in transit. So it does that verification and confirms that. Okay, that's it about the NTP and NTS. So NTS is the security layer that is added to NTP to ensure that we have a network time protocol that is secured. Then we go to SNMP. You see, there are a lot of acronyms in security, a lot of them. SNMP security simply means Simple Network Management Protocol. Simple Network Management Protocol. Now, again, I like using Allegri. Think of this SNMP as a building manager. And what this building manager does is that he says, I am the one in charge of this building and I have an asset list. Let me check. I have 10 assets in this building. Then let me check my checklist and be sure that the 10 assets are actually present. So that's what SNMP does. SNMP is like a building manager who checks on all the machines in the building. Then it has some components or some parts. The first one is the SNMP monitor. It's the main control center. See it like a security guard station in that building. Then there is another one called the agent. So this agent serves like a little EPA programs on each device. So this might be the sensor that is in each room for monitoring. Then there is also another component, the MIB component. We call it management information base. So this is a database that stores information about each device. So all the stuff that are in that building are tracked by the MIB as a management information base. So SNMP is the central management station. Agent is a process or network device like the switch, like the router, like the server. Then MIB is what does the management of information. That's management information base, the database of every device and their statistics. So just like a report card for each of those machines. Then this is a trap. Whenever things go wrong, SNMP will cry out for automatic help. See it like an alarm in the building when things go wrong. So it's an agent. The agent notifies management system for notable events. So when things go wrong, the agent will sync to an action like a switch, an alarm, a router, a server, and it will notify the management system of notable events that had occurred. So see this chart, the SNMP manager, we can see that there is a double-way communication between the switch, the router, and the server. These are the agents. The MIB are connected to this. This fits in to another system and give them information about the situations. So the MIB system. So whenever things go wrong, the agent gives alarm, or the agents, they give alarm and notify the central system or the management system of the outage or the event that is actually going on. So we have some versions of SNMP. These versions, version 1 and version 2, they are old and they are insecure. They use community strings. That means just use normal string, non-protected. And they are basically what anyone can see, what anyone can know. So that has a problem with version 1 and version 2. V1, V2, they use community strings, the insecure strings of character. But for V3, V3 is hardened, security hardened. It has real authentication that prove who is accessing what, and encryption also is integrated with version 3. So that's it about the SNMP, which is a simple network management protocol. Now we go to TLS itself. TLS, as we've been saying, it simply means transport layer security. Transport layer security. So what does it mean? That's the question we're going to ask ourselves. So there is this story behind it. SSL, which is secure socket layer, was created first of all in the 90s and created by the company called Netscape. And of course, as we know, with every technology, there is always improvement based on observed vulnerabilities. So it was designed earlier on. SSL was designed to secure the HTTP protocol. But eventually, it quickly adopted as TLS standard. So what does it do? It creates a secret tunnel between the computer, your computer, for instance, as we're working online now, as we're communicating online. So there is a tunnel that is created between our computer and the website or the platform we're using. Now, everything that goes through that tunnel is scrambled, that is secured, is encrypted. So no one can read it. So how does it work? That will be the next question. The TLS implementation. We've talked about some of the components before now, when we talked about the encryption methodologies, and we talked about the digital signature, we talked about certificates. So how TLS works is, one, it has a digital certificate. So this digital certificate sits as an ID card that is signed by a trusted authority. So the server assigned digital certificate signed by the CA, that certificate authority. The second thing is certificate proves server identity. So the certificate proves the website is who it says it is. So if I'm accessing abc.com website, so my computer and the website, we have a communication, and through TLS, the certificate of that website will be confirmed and will be confirmed to be sure that it is actually abc.com that it has claimed to be, that it is. So when that has happened, the next level will be the validation of the server's public private key pair. Then the next thing will be that the encryption will take place, and then there could be normal communication between our system and the internet. Now, we have some versions and they are depreciated. That means they are insecure, they are depreciated, they're no more in use because of their insecure status. SSL 2.0, SSL 3.0, TLS 1.0, TLS 1.1, these are insecure. They are insecure protocols and they are depreciated. The current secure one, the widely used one is actually TLS 1.2, but there is the latest that came in 2018. So this TLS 1.3. So TLS 1.3 prevents downgrade attacks, and it does that by blocking off any insecure features. So we say the secure versions of the TLS will be 1.2 and 1.3. So the 1.2 is the one widely in use. Okay. Then we go to what we call the Cypher Suite. Cypher Suite. We've talked about this as well. When we say plain text and encrypted text, when you have your plain text, is the real word, the real message that everybody can read. English language, for instance, text. But it becomes a cipher text when you have encrypted it. So a cipher suite then is like a recipe book, or what we call a set of algorithms that tells to computers, for instance, how to scramble and unscramble their secret message. For instance, we have the ECDHE, that is elliptic curve, Diffie-Hellman ephemera. We have talked about this. The RSA, the Rivest-Sadmier-Adleman, the AES 128. So that's the advanced encryption standard with 128 key bits. Then this GCM is Galois-Cantor mode. And SHA-256 is a secure hash algorithm using 256 key bits. No. So these are the cipher suite. And you will notice that they are concepts we have covered before now when we're treating public key infrastructure, talking about the symmetric and asymmetric keys. Okay. So again, let me talk about ECDHE. That is this elliptic curve Diffie-Hellman encryption. Ephemera rather. Elliptic curve Diffie-Hellman. So Diffie-Hellman is a guy. It's one of the guys that invented this key. Diffie-Hellman also is another guy. These two guys, they are guys. Diffie-Hellman, two names. Then the name of the curve is elliptic curve. Okay. It's being used by. It's used by a crypto. It's used in cryptocurrency. Okay, so let's talk about that. This is how this algorithm is used for key agreement. Then ephemeral simply means, just like we say, anything in this world is ephemeral thing. That means anything in this world does not last. It's just for a while, transient. No. So it means that for every new session you initiate, for every new process you initiate, during the course of your activity, a new key will be created. So when you do, for instance, maybe a session lasted between 5 seconds of 1 minute, and you want to initiate another session. So that's 1 minute, initial 1 minute has become an ephemeral session. So a new session will be instantiated on a new key. So that's where ephemera comes into it. So it means that if one is stolen, it only affects that one conversation. If our conversation is broken into 10 blocks and one of our keys were stolen, that stolen key will only compromise that block where we had a communication. The other 9 sessions are secure. The next one is RSA. RSA does work of verification of signatures. So you can use to verify identities using signatures. And the inventors, as I said, Rivers, Samir, Aduman, their initials. Okay, we have already talked about SHA-256 before now, which is used for HMARC, hash-based message authentication code. So this one I used to ensure the integrity of data, of messages, of communications. Then they do one thing, which is known as perfect forward secrecy. That's what I explained before using the term ephemera, that even though one session is hijacked, the entire session is secured. Or it's only that hijacked session, that hijacked key that can be compromised. The others are secured because we're using ephemeral keys. Okay, the next protocol we want to talk about is the HTTP and HTTPS. Again, this is not new to us. And by HTTP, it means Hypertext Transfer Protocol. It's a protocol. Protocol simply means set of rules that we have agreed upon. So we say, okay, anytime I want to communicate with you, confirm, number one, that I say, I am Mr. Shea. I am this here. So we have already aligned before time that I just need to tell you three things. And once I confirm those three things, we are fine to communicate. So that's a protocol, rules, set of rules that have been agreed upon. Hypertext. So it's an hypertext mode. So what do we mean by this? HTTP again is a language. And this language, just like Hausa, Igbo, Japanese, those who know those languages use the languages to communicate with one another. It turns out also that our web browsers, they use hypertext transfer protocol as a language to communicate with one another. For instance, when a link is clicked, pam, the browser will send an HTTP request. A request is made using the language of hypertext transfer protocol. Now, there is something called statelessness. It means hypertext is stateless. What does that mean? The website doesn't remember you between your clicks. It doesn't remember you. We call it goldfish. It doesn't remember you between. It's a stateless protocol. Server preserves no client information during session. Now, when the client requests resources from server, so my system now, if I'm on the laptop and I'm on a particular web browser, my system is a client. I am making a request from Google browser and Google server. So the client making a requesting for a resource, whatever I'm asking for is a resource from Google server. It's either two things happen. Either I get a data or I get an error. But then in the process of these clickies, there is statelessness. What are the methods? We have four methods. The get, the post, the put, the delete. Five rather. Get, post, put, delete. There is also add. It's not showing. Delete, then add. When we say get method, get, we say, give me this message. Like, I'm asking for a menu. Post, we say, here is some information. So like you are filling out a form. Then put, we say, save it here. So like, for instance, you're uploading a file. Then delete, we say, remove this. Then Ed will say, just tell me about this, don't send it. So you are checking if a package exists. So those are the methods: the get method, the post method, the put method, the delete method, and the add method. That's how HTTP operates. But now we go to HTTPS. Again, the S part is the security there. So the security layer there is the TLS that is added. And this TLS, like we said before, is a transport layer security. The transport layer security. So when we had the TLS, so we add it with HTTP. We're going to have HTTPS. I will see it these days common when you are visiting a web browser and it shows a padlock with HTTPS. If there's no padlock there, it means it's just an HTTP and it is not secure. But with HTTPS, so there's going to be a padlock, and then it shows that this browser or this website is secured. This communication is secured. HTTP uses port 80. 80, that's very important. That's the port 80. I've talked about some ports today. We've talked about port 123. We've talked about port 636. And we've talked about port 483. So HTTP uses port 80. Then HTTPS uses port 443. 443. So this one is a secured port. Port 80 is not secured. Anyone can read it. Then there's something we call the security headers. Those who, if you build websites, I've come across this before my the process of me building some websites. So we need to take care of this aspect of security headers when we are building websites to protect the website from some attack vectors. So we have a HSTS as a security header. So this will enforce strict transport security. That's HTTP strict transport security. So the H here means it stands for HTTP. Then a STS, not search the scriptures now. It means STS, that's strict transport security. What this does is it forces, it compels the browser to use only HTTPS. It enforces it. That's the header. HSTS, HTTP, strict transport security. Then the next one is the CSP. The CSP means content security policies. So this, when this is enforced, it will enforce the rule that can run on the rule about things that can run on a web page. Sometimes if you are in production mode, you can set it to accept some rules. I'm sorry, when you are in development mode, that means you are just building it. You can allow it because you need to test some things. But when you go to production, you have to change the CSP, the security header, considering the CSP, and force it on things it has to accept. Otherwise, some content could be altered. Some rules could be changed through external people, and that will compromise the security posture of that particular website. So that's the CSP, control security policy. Then there is also another header called cache control. So with cache control, it says, don't save sensitive information. That means it prevents caching sensitive data. So it tells browser not to save sensitive information. So that's what these three headers, that's what they do. So HSTS as an header enforces HTTPS only. That is the hypertext protocol. Hypertext protocol with TLS is enforced automatically. Then the content security policy, the CSP, states the rules on what can run on a web page. Then the cache control, it prevents the browser from saving sensitive information. Okay, then we'll go to another protocol. Here we call it SFT protocols, secure file transfer protocols. Secure file transfer protocols. So in secure file transfer protocols, this is just a way of telling computers how they send files to each other. For instance, like email for files. But the original one, the traditional method before used to be FTP. That's file transfer protocol. It's very popular and it's been used for file transfer. It has wide cross-platform support, but it suffers from security mechanism. No security mechanisms, because credentials are sent in a plain text. This is very dangerous. Attackers, threat actors can hijack the session, steal the credentials and harvest them for malicious use. So FTP can send your username and password together, like I said, just openly as a plain text. So the safe alternatives for FTP is the SFTP, where S stands for SSH. SSH means secure shell. Secure shell. SSH, then we have FTP. That means secure shell file transfer protocol. The first thing you need to know about secure shell is the SSH FTP. It uses port 22. Port 22. Then another thing about it is that everything that is in there that is sent through it is encrypted. And you can also have a fine control over whatever is sent through this port. SFTP, that is secure shell file transfer protocol. Now let's see some of these ports. Protocol, we have FTP, that is file transfer protocol. This is insecure, so we use port 21. The secure shell file transfer protocol, SFTP, uses port 22. Then the FTPS, that means adding security to it now. This is implicit. It uses port 990. Then FTPS is explicit. It uses port 21. Now, there's something we need to know. What do we mean by this FTPS, then the FTP? So that means we can add TLS to our FTP. So when you add TLS, that is when you add the security layer to it. That's when you have the FTP. So with FTP, you have TLS, transport layer security. You add it explicitly. You add FTP to, you add TLS to FTP to ensure security. So you can look at it this way. We can say that FTPs are in two types, the explicit and the implicit. So for the explicit TLS, that is the FTPS, it starts normal, then adds security of port 21. Then the implicit TLS is secure from the start. So that's the implicit configuration. It's implicitly configured to start with security. But the FTPS, this one starts initially as a normal state, but later on adds security during the course of operation. That's why it is explicit and the implicit. So what we just need to know is FTP uses port 21 and it is secure. It is not secure. SFTP, that's secure shell file transfer protocol, uses port 22 and it is secure. Then FTPS, that's file transfer protocol security. That's when you had TLS to it or you had SSL to it. That means you take you do your FTP protocol over TLS layer or over SSL. So that means you are adding security. And this security, you could add it implicitly if the security is added at the beginning of the procedure using port 990, or explicitly starting on a normal way. The normal way, and then adding security to it.
This port number,
yes,
should
sir.
you put it in memory?
Yeah, they are very easy to memorize. Yeah, it's cool if one can memorize them. It's cool.
Does it come out in exam? So what's the ports of FTP, HTTP,
Before now,
HTTPS?
it used to be a major question. A major question point before now. But there's a kind of downplay on the implicit knowing of those protocols. But of course, it's something one we want to know, even apart from exams. Or it's something one we want to know. So just to know, okay, which port go for which port go for which port. Okay, sir?
Okay, thank you.
Okay, then we'll go to email protocols and ports. So this concerns us a lot as well, because email happen to be the baba of attack vector, is actually a target point. Okay, email protocols and email ports. So we have the SMTP as a protocol. Then we also have the other protocols as well. So the question is, how does it work? We need two types of protocols for emails. And these two protocols, number one, as I said, is SMTP. So we use it for sending the message. So SMTP means simple mail transfer protocols. So this way, it shows the way email leaves a computer to the email server and then to other servers. So that means the way the email is sent out to the recipient, going through some servers. Okay, we have some ports that are used for emails in this the SMTP. So we have port 25. So port 25 is server to server. Server to server. Think of it this way, like post offices talking to each other. That's server to server. I've sent a parcel from my house to a particular parcel or courier services. There are transactions that happen between this courier service and the other courier service. Maybe they are also giving this service to another third party, which I don't know, but they know. So there is a communication between this server and this server, this courier and this courier. The another port is port 587. In this way, it is between computer to server. So think of it this way. I picked my parcel and I went to this particular post office or this courier delivery service and I give them my parcel. So this is communication between the computer and the server. That is port 587. Port 587 under SMTP. Client submit. Then port 25, server relay. That is server to server communication. The another one is a port 465. This port 465 is implicitly TLS. So that means it's a secure version of SMTP. The secure version of SMTP. So that is for, you can see SMTP is simple mail transfer protocol. That's just protocol. But when S is added, it becomes security. And by that, you are using TLS with SMTP. So it's a secure version. So that is the first protocol for sending. The first one is to send email using SMTP. And when you make it SMTPS, you are talking of adding security layer to the sending protocol for your email. So the second one will be the mailbox protocols. So this one handles the receiving of the sent email. So here we have a POP3. POP means Post Office Protocol version 3. That's a POP3. POP3, Post Office Protocol version 3. So what this do is it download emails to your computer. Then it uses some port as well, port 110, which is insecure. Then POP3S. So here you have added TLS to it. That means this POP, Post Office Protocol version 3 with secured layer. So this uses port 995, and this one is secure. So this thing addressing how emails are received. Then there is the IMAP4. 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 IMAP simply means Internet Message Access Protocol version 4. Internet Message Access Protocol version 4. I say it again. Internet Message Access Protocol version 4. For what this 4 does is it manages server and multiple clients. So it keeps mail on the server, and with that you can check from multiple devices. So the email is received. The other one we said the POP3 downloads it to your computer, meaning it is when you download it you can read it. But with IMAP4, it will download it to the server, and you can now use multiple devices to check it on that server. So it means that this protocol is device agnostic. So it supports devices. And here we have 2 ports again. For IMAP4 without security, insecure one, we use port 143. Then when you add TLS security to it, and you have IMAPs, so you're going to have a port 993, and that is secure. Okay? So there is this concept we call start TLS. With start TLS is a command, and the command is to upgrade an insecure connection to secure connection. So it's you start a message, and in between you put an armor mid conversation to secure the connection. So we call it start TLS. It upgrades insecure connection to TLS. It's also called explicit TLS or opportunistic TLS, meaning that you start in a normal way, but along the line you switch over to secure communication. Unlike implicit, with implicit, it is designed into the system from the go. But with explicit, it is upgraded as a need arises in the communication processing. And that's what we call start TLS. Okay. Let's take voice and video security. Voice and video security. So we call the protocol VoIP. VoIP. With VoIP, we call it voice over internet protocol. Voice over internet protocol. So this is the protocol that guides phone calls over the internet. What it does with SIP, session initiation protocol. So what it does is it sets up and ends voice and video calls. For instance, like dialing a phone number, but now for internet calls, not the mobile calls, internet calls. So it's SIP that is guiding that. Session initiation protocol is SIP. It establishes, it modifies, and it terminates voice and video sessions. Then there is the RTP. RTP means real-time transport protocol. Real-time transport protocol. So what this does is a carrier of the voice and video data over the internet or over IP networks. It delivers audio and video over internet protocol networks. So we have some versions, just like in other protocols we have looked at. So we have secure versions and we have insecure versions. So where we have no S, it's not secure, but we have the SIPS, for instance, which means secure SIP. That means TLS layer, TLS is added. TLS mechanism is added. That's why we have SIPs. Then we have the SRTP, which is secure real-time transport protocol. That means we have encrypted media. But there are some concerns over the VoIP, that is the voice internet protocols. So there are some concerns, and the concerns are not far-fetched. One of them is what we call the eavesdropping on calls, like somebody is putting his ears or putting her ears at the door and listening through hiding to the information that is being communicated. So listening to calls, it could be wire taping. You could tape the wire and divert communication to another room or another server or another network setup where you could actually hear clearly what the other parties are communicating or what they're discussing. So we call that eavesdropping. Then there is the one called the call injection. Call interception. Which call interception is synonymous to plain hijacking. So you hijack calls, and those who are supposed to listen will receive that. They can't receive it because the call has been hijacked. Then the other one is caller ID spoofing. In this one, you pretend to be someone else. So the other guy is tricked. He will think he's communicating with the bona fide recipient of that message, not knowing that someone has spoofed on him or spoofed on her. Then there is the denial of service. And there is what we call the toll fraud. In toll fraud, you are making expensive calls on someone else's account. Toll fraud. So how do we mitigate this? Of course, it's good to use secure real-time transport protocol. Then we can implement the SIPs we have talked about, secure SIP, session initiation protocol. And we can segment voice internet protocol traffic. We can segment them so we can really monitor where things are going wrong. Okay. I want to talk about the email authentication. Email authentication. For email authentication, there is the SPF, the DKIM, then DMARC. So I'm really taking time like this because the concepts are very, they are technical and new. So I might stop here because of the different concepts we have talked about. So we can pick it up from there. Tomorrow, we are meeting tomorrow. So we can pick it so I will not overload you. But let me talk about email authentication now. Okay. So we have what we call the big three email security systems. And they are these SPF, the DKIM, then the DMARC. They work together. And in their working together, they synergize to ensure that fake emails are stopped. So how do they work? SPF is Sender Policy Framework. Sender Policy Framework. So here, the framework confirms who is allowed to send email for this domain. So we have a list of approved email carriers, mail carriers, that say, okay, these approved lists are the ones that can send parcels. So in SPF, there's a framework that shows us who are the people that are given act that are allowed to send email for this particular domain. Then the DKIM, that one is domain keys identified mail. So what this framework does is to confirm, is this email really from who it says? For instance, you confirm by signature, the digital signature, which confirms the sender and the messenger integrity, the message integrity. So the SPF confirms who are allowed to send email for this domain. The DKIM confirms this person that is actually sending, is it the real one? Is it the real person? Okay. Then the DMARC. DMARC means domain-based message authentication, reporting, and conformance. Domain-based message authentication, reporting, and conformance. So the question is asked is, what should we do? What should we do? That's the question here. SPF is, the keyword in SPF is allowed. The keyword in DKIM is really from. The DMARC, the keyword is do. What should we do if SPF or DKIM fails? So like the last line of defense. So for instance, if the seal is broken, throw it away. That's what we should do. Reject it or quarantine it or do something else. So together they make sure that the email system is really secured against scammers. So it's mainly for authentication. Okay. Okay, let me get it through to the questions. Let me cover these 3 slides. And I'm going to stop on the questions. Okay. For today. So we can continue. So the next now will be the Sender Policy Framework, SPF. Sender Policy Framework. And the question is, what is SPF? Think of it like the guest list for email senders. The guest list for email senders. Sender policy. So it detects and prevents sender address forgery. And this is usually used in phishing and spamming. So how it works. Think of it like there's a mini company. So you own a kind of an address. Let's say you have an address called mycompany.com. And now you publish a list saying only these computers can send email as at mycompany.com. So when someone receives email from at mycompany.com, they check the list. So if the sender isn't on the list, the email might be fake. So example will be this breakdown here, the SPF DNS record. So you have this V, then these are other codes that are associated. So let's try and analyze them one after the other. So V is this. This one means the SPF version. Then the IP4 shows us the allowed IP range. So from IP4, so we have this range of IP that are allowed. Then it says include. So include or another domains SPF. Then it say all. Here it means reject all others. So that's the rule. So it's a special note in the DNS phone book that contains the SPF rules. So that is the DNS record text. So this record contains this kind of information, and this information is used to carry out the sender policy framework. Okay, so that's about this how SPF, how it works. So here is just authenticated that the sender, is it actually from this domain, or someone has faked or forged this email to look as though it was real. Okay, the DKIM or domain keys identified mail. So what does it do? As we said earlier on, this checks for the integrity. Sorry. I'll get back to you.
Okay, no problem.
Sorry, sir. I just want to return something. Okay. So as I said before, that the DKIM. Hello, sir?
I'm with you. I'm with you.
The DKIM is used to confirm the integrity of the message. So it verifies the authenticity, which handles the integrity of the CIA triad. And you can see that, as we said earlier in the course of the training, that the idea behind cybersecurity is to ensure the CIA. So everything we do always revolve around these blocks. So I is integrity confirmation, and DKIM confirms that in email authentication. And it's also the digital signatures that we dealt with when we treated public key infrastructure that is also used. So what are the procedures for this? The sender, the sending server signs email with private key. The signature added to email header. The public key published in DNS record. The receiving server now verifies signature. So it confirmed that this email really came from who it says it's from. It authenticated and it confirmed that nobody changed the message. That's the integrity. So the email is sent. Your server, where you are the one sending the email, your server automatically uses a digital signature on the email. So the signature is now created with a secret private key. It's your server that knows that. Then the public key from your server is published in the DNS, so anyone can see that. So when someone receives your email, they use the public key that your server has publicized to verify the signature. So the private key is secret key only you have. That is only your server has that, where you are sending the email from. So the public key, this is a key you share with everyone, which is published to the DNS when the email is sent after being signed with a private key of yours. So if the signature matches at the end of the day, from the end, because since that public key came from you, it is believed that your private key has signed it. And that is why it can confirm your identity. So if the signature matches, the email is real. If not, it means someone affected it or changed it in the course of transmission. So the sender signs. So we have the email now plus the signature. At this point, the DNS published the server published the key, your public key to the DNS. Then at the receiver side, the receiver verifies through the published DNS, through the public key to verify that this indeed is a signature that comes from you. Okay. The DMARC, the last point now, which switches on when others have done their job. So for the DMARC, which is again domain-based message authentication, reporting, and conformance. So this is the referee in the way. And as a referee, it decides what happened after SPF has done his job, after DKIM has done his job. So it does this thing. Number one, none. Just watch and report. Monitor, just monitor. That's a learning mode. So DMARC can tell receivers like that, can say none. That means do nothing, just monitor only. Also, at another level of escalation, DMARC can tell the receiver, quarantine. It says, that's why you see some emails go to your spam folder. So DMARC does that job. They quarantine this one. Put suspicious emails in spam folder. Then it could, again, even go to another level of escalation and says reject. So here it says block it completely. Don't even put it in any quarantine. Block it entirely. Then it could also tag it. Say mark it as suspicious, but don't quarantine it. So DMARC always provides reporting on email authentication. So DMARC also sends report back to domain owners. The intent is that they also can know and see who is trying to fake their emails. So it reports back to the domain owners. And as the email gateway now, so what do we have in email gateway? So it sounds, as it sounds, that's how it is. Gateway is a gateway. So an email gateway is like a security checkpoint for all emails coming in and going out. So as a gateway, it implements anti-spam filters that block spam messages. It implements antivirus scanners that scan for viruses. Then it also implements phishing detectors that detect any phishing activities. And as well, it also implements malicious URL detection, so that checks for any links in the email that are appearing or that are malicious. Finally, it does scanning of harmful attachment. So it scans attachment for malware. So these are the things that happen at the gateway. So let's take this question and end it for today here. Can you read it, sir?
A company wants to prevent attackers from spoofing their email domain. Which DNS record type should they implement to specify which mail servers are authorized to send email on behalf of that domain? No, seeing S there, I will go for B.
B.
I believe S.
Yeah, you're right. B, that's a sender policy framework.
Yeah.
So with sender policy framework, there is the specification of authorized sender IPs in the DNS text record. And this prevents domain spoofing. You are right. Thank you, sir. Okay, and we're going to call it a day here today, and we continue tomorrow on this. Thank you, sir. God bless you. Or do you have any questions?
No. No questions, sir. Thank you very much.
You're welcome, sir. Take care, sir.